Okay, class. I'm not here today. This is going to be your activator. Your objective for the day is that you will be able to, let me move this, classify covalent compounds as polar or nonpolar based upon their shapes. Today's activator is coming directly from the lab that we did, and I've added two more things, metals and nonmetals, and I want you to use your logic to figure out this chart. What I want you to do is, where it says solubility, and I mean solubility in water, write yes or no. Melting point, I'm looking for a high or a low melting point. And for conductivity, again, just use yes or no. I would like to substitute to pause the screen right now and give you a few minutes to copy the chart down and do your best to answer the questions. I wrote you in pencil because when I come in on Monday, we're going to go over it and you don't want it to be a mess. I thought a good place for you to copy this chart down would be on the back of your Venn diagram. Could the substitute please pause now? I want to talk about polarity. We have a couple of clues. We can use our electronegativity table and values to tell if a covalent compound is polar or nonpolar. Or we can follow a couple of simple rules. The first one, let me do a blue, let me change it to blue. It says no electron pairs around the central atom. And when I'm talking about a central atom, of course, we're talking about a molecule that has two or more elements. If there is no electron pairs, then we can most of the time say they're nonpolar. However, if we have leftover electron pairs around the central atom, then we can say they are polar. So what I want you to do is to write down these two statements, maybe on the back of your homework paper, and underline what I've underlined. I'm going to ask the substitute to pause for a moment and allow you to continue to write these down. Now, following these rules, I've got 5 shapes on the board. These are the only 5 shapes you are required to know for this course. I want you to take what I've shown you up top and write down number 1, 2, 3, 4, and 5, and just tell me whether they are polar or nonpolar. I will check your answers when I come back in on Monday. The substitute should pause the screen again so you can write down the answers, polar or nonpolar. All right, let's get right to your notes. The title of the paper says vsepr theory, shapes of molecules. I'm going to tell you what it means. It means valence shell electron pair repulsion theory. It says the directions to use your textbook as a guide, but I'm going to have you do that for the BCR section only. And I'm going to explain to you what the different shapes are. The first one we have is linear. Here's an example of linear. The first thing I noticed is that there are no electrons around the central atom. There's nothing there. So is that going to be polar or nonpolar typically? Well, I'm going to tell you that it's going to be nonpolar because there are no electron pairs. And I say typically because there's always an exception to the rule. Here are some examples. Hydrogen, H2. Any diatomic molecule, which you learned yesterday, by the way, is going to have an electronegative value of 0, and it's going to be nonpolar. CO2. Why is it nonpolar? because there are no leftover electron pairs around that carbon. All of the electrons around carbon are involved in a bond. I'm going to ask the sub to pause the screen so you can write these notes on your paper. The next one is angular bent. I usually just refer to it as bent. Here I have linear. We can compare the two. What is the difference? Well, I happen to see electron pairs around the central atom here, but not here. So what can we say about angular and bent? If you said polar, you're correct. Two examples would be, ooh, look at that, water. And does anybody remember what that is called? If it's not water and it starts with an H, it's what? Hydrosulfic or sulfuric acid. Notice each one of these has these two electron pairs left over, and it pushes the hydrogens away, pushes them down. I'm going to ask the substitute to stop so you can copy down these examples. Okay. This says trigonal planar. Say it with me. Trigonal planar. Trigonal planar. I'm going to give you an example that we already did in class, and that would be boron trifluoride. There are no leftover electron pairs around the central atom. So what you can see is that it's even Steven all the way around. It's perfectly symmetrical and beautiful. No electron pairs left over. So typically, it's going to be what? Nonpolar. So here are some examples. Oh, look, boron trichloride. I'm going to ask the substitute to pause and give you a moment to copy this down. And remember what I said, typically. Okay. This one is trigonal planar, and this one is trigonal pyramidal. Why is it called pyramidal? Well, it looks like a pyramid, doesn't it? Let's see, let me draw a little pyramid here. Okay. There's a little point at the top. All right, now I don't know how to draw, so no busting on me while I'm not in class. Okay, trigonal pyramidal. What is the difference between the two? Well, I can see it. This one does not have any lone electron pairs, but this one does. So what is that typically, again, going to tell you about that type of molecule? There's always exceptions, just remember this. That it's going to be polar. So here I've got ammonia and phosphorus trichloride. So I'm going to ask the substitute to pause so you can copy down these examples. And our final shape is the tetrahedral. The tetrahedral. This is, tetra stands for what? Tetra. The prefix tetra is equal to 4. So it's one central atom, right? And it's got 4 atoms surrounding it. Tetrahedrals have no leftover electron pairs. See? And they are typically nonpolar. Here we go. Remember in class, for this one, for the electronegative values for carbon tetrachloride, it came up to be polar. But I'm telling you it's nonpolar. And it's nonpolar because there's no electrons on my central atom, and there's none here. And you look, it's chlorine, 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 chlorine. All of those negative values kind of cancel each other out. So it is non-polar. It's not charged in any way, shape, or form. And all these fluorines, again, cancel each other out. And there is no electrons left on carbon. And again, I ask the substitute to pause while you write down these examples. Okay, for your work today, what you're going to do is complete the BCR on the back of this paper. The BCR, look, I'm taping it, I still can't find paper. It says, for molecules having 4 pairs of electrons surrounding a central atom, the bond angles are not always equal. Explain what causes the bond angles to be different for tetrahedral, trigonal pyramidal, and angular bent molecules. So those 4, or there's only 3 of them. Lucky you. I want you, myself, I want you to go through each shape, starting on page 411, and write down the bond angle for each one. And what I mean is, here's water, okay? There's a particular bond angle that I want you to write down that's going to be indicative of a bent molecule. Before you get started on that, I want to go over the homework with you, and then you can go and get your textbooks and get this finished. 411. I want the BCR turned into me by the end of class. Here's the homework. It says Lewis dot structures for molecules with single and multiple bonds. What you're going to do is, you're going to take the paper that we did in class on covalent bonding. You're going to draw the Lewis dot structures for the molecules, following these 3 rules that I gave out yesterday in class. You're going to draw their proper shape according to the shapes you have in your notes, and you're going to tell me if they're polar or non-polar. So let me go back. Well, actually, let's have the sub pause the screen here for a moment so you can write down what I need, because I've added this section to your homework. And see, why am I doing everything in purple? Woohoo, go Ravens, woohoo, happy Super Bowl. Let me go pause the screen here. Please substitute for a few minutes. Let them write down what they need to write down. And then go back to the previous screen, which is here. Complete the BCR section. All right. That's all I have. Have a great day.